Hey guys, this is Mr. Mood. Today we're going to talk about the introduction to rate of change. By the end of this video, students will know what the delta symbol represents. They'll also know the definition for rate of change, and students will also understand how rate of change is used in the real world. So let's start by answering the question, what is rate of change? Rate of change tells us how the dependent variable changes in relation to how the independent variable changes. For example, 40 miles per hour is a very common usage of rate of change. It's the speed of a car. In this scenario, the dependent variables is the miles, independent variable is the hours. So the dependent variable is changing by 40 miles, and the independent variable is changing by 1 hour. Rate of change is expressed as the following ratio. I have change in the dependent variable divided by change in the independent variable. I can simplify all that by using a special symbol, the triangle symbol, which is actually called delta, to replace the words change in. So whenever you see that triangle, it really means change in. So I can simplify the top to be delta dV, and the bottom to be delta IV. Even more simply put, I can put delta y over delta x. So let's talk about how delta works. Delta works by subtracting the starting value from the ending value. For example, the temperature outside was 54 degrees this morning. Now it's 75 degrees. What is the change in temperature, or delta T? So delta T is calculated as the ending temperature minus the starting temperature. My ending temperature was 75, my starting temperature was 54. I take those two numbers and I subtract them, and I get 21. So delta T is 21 degrees. The temperature outside was 74 degrees this afternoon. Now it's 60 degrees. What is the change in temperature, or delta T? So delta T is still ending minus beginning. In this case, I have 60 minus 74, which gives me negative 14. So delta T in this scenario is negative 14 degrees. If delta is positive, that tells us the quantity is increasing. For example, in my first scenario, I got a positive 21 degrees. That tells me I'm increasing by 21 degrees. If delta is negative, then the quantity is decreasing. In the second example, I got a delta T of negative 14 degrees. That tells me that I'm decreasing my temperature by 14 degrees. So rate of change can be expressed in the following ways. I have delta dV over delta IV and delta Y over delta X. Let's explore how we would use these in a real-world situation. In 1972, the average movie ticket cost $1.55. In 2011, the average movie ticket cost $7.95. What is the rate of change for the ticket price per year? So the ticket price per year tells us that my top number should be ticket price, my bottom number should be year. So it means my dependent variable is ticket price and my independent variable is years. So delta dV is going to be $7.95 minus $1.55, which gives us $6.40. That goes on top of my ratio. Delta IV is 2011 minus 1972, gives me 39 years. That goes on the bottom. Then I take my calculator and I divide those two numbers by one another, and I get 16 cents. So the rate of change for the ticket price per year is an increase of 16 cents per year. That's basically it for rate of change. Rate of change tells us how the dependent variable changes in relation to the independent variable. It's expressed as the change in the dV over the change in the IV. We can simplify that by using the delta symbol to replace the words change in. So we basically get delta dV over delta IV, or delta Y over delta X. And delta is calculated by doing the ending value minus the beginning value.
That's all, folks.